Hey there, it's Jason Gorman from Codemanship with another video diary entry. Before we begin, if you're enjoying these videos, please like and subscribe and ring the bell for notifications for new content. Okay, right, I wanted to show you a bit of code today. This is code that calculates square roots. So you give it an input number and it calculates the square root of that number. And the way that it works is it starts by taking a guess. This is its best guess, that the square root is half the number. Of course, that will only work for 4 and for 0 as well, of course. But it takes a guess. It tries to get us in the ballpark with a number that is lower, roughly half, is exactly half, in fact, of the input number. And then what it does is it loops round and round and round. And it does a little calculation here where essentially it calculates how far away we are and then splits the difference, if you like. So it's a process of essentially getting it less and less wrong. And the idea is that this will eventually converge on the real square root, and the point at which the guesses that we're taking stop changing. Basically, the current guess is the same as the previous guess. At that point, we'll say it's converged on a number, and we'll exit and return that square root there. And it does appear to work. Now, I've put in a couple of console logs here. This is a Node.js little project. First of all, we're outputting each of those guesses at the square root. So every time we take a guess at the square root, starting with the first one of half the input number, we'll log that to the screen. We're also counting the number of times we go around the loop, counting the iterations. And this is then being output at the bottom here, telling us what the square root of that number is and how many iterations it took. So we can see the workings of this if we run it at the terminal. So let's run our maths.js. You can tell I'm English, maths.js, not math. Square root of 9. So the square root of 9 is 3, as we all know, hopefully. And it took 6 iterations, basically, starting with the initial guess of half of 9, 4.5, and then gradually splitting the difference down and down and down as the difference is getting smaller and smaller. We converge on the working solution, the correct solution. And we can do bigger numbers, so we could say, what's the square root of 25? And you'll notice it took an extra iteration because half of 25 is further away from the real answer. Our initial guess gets further and further away from the real square root, so it takes more iterations. Let's do a big one. Let's do a square root of 10,000. Should be 100. There we go. So it takes a few extra iterations. And the interesting thing about this is the farther and farther we get from the ballpark, it's kind of exponential, really. It doesn't involve an exponential increase in iterations. It doesn't involve an exponential increase in iterations. So I can increase the number exponentially, and we will get a sort of a linear or a logarithmic increase in iterations. So it took 13, so 10 times the number. So we're 10 times further away from the ballpark than we were before, but it only takes an extra couple of iterations. Now, that initial guess, in fact, you can see here, we could put anything in here. Let's make it 10,000. So we're far away. If we do the square root of 9, we're far, far away. So if our initial guess is pretty wrong, but the iterating process will eventually fix that. With enough goes round, with enough iterations, we will reach a working solution. And you're probably wondering, Jason, what has this got to do with software development? But it's about those initial guesses and the true nature of software development. There are many teams out there who, first of all, make the mistake of trying to get their initial guess right first time. They're trying to get it right first time. Now, there's only one number that will work for, that will only do one iteration, and that is if we do the square root of 4. So the square root of 4 is half of 4. So, oops, it took 18 iterations because I didn't do that. Let's just change that back. Let's try it again. Square root of 4. So it only goes round once. Now that's the one number that it will only do one iteration for. All the rest are out. It'll need to do more iterations. And the whole point of this with requirement specifications in particular is that they are going to be wrong. No matter how hard we try to get it right first time, it's going to be wrong. Just like our square roots here. It's astronomically remote probability that we will guess the square root right first time. It's an astronomically remote possibility that we will build the right thing first time. So we must expect to go again and again and again and again and again, gradually converging on a solution that the customer and the end users are happy with, sort of splitting the difference each time, if you like our square root algorithm. Now, that shifts the emphasis in two ways when we're doing software development. First of all, it shifts the emphasis away from delivering features or delivering on specs, requirement specs, to solving problems. Solving problems. If you're not trying to solve a problem, you can't really iterate because your feedback is meaningless. Did we solve the problem or didn't we solve the problem is the important question. And then we can refine on that. As long as we get in the ballpark, we won't have to do too many iterations, hopefully, to reach something that works. That's the second emphasis shift that I want to encourage you to try and build into the way that you work as a team, as well as organizing around solving problems instead of delivering features. You also need to shift the emphasis in development from getting it right first time to iterating, being able to go round and round and round and round and round. And in order to do more iterations, your iterations need to be faster. If I were to put in a delay in here of a second for each iteration, this algorithm would start to get slower and slower and slower. As it is, it's very, very fast. Each go round is just costing us a fraction of a millisecond, so it's a very fast algorithm. So what we learn from this, or certainly what I've learned, is the fastest, most effective way of figuring out what the customer really needs is to give them something that's hopefully in the ballpark, but actually if it's not really that far into the ballpark, it's still not a big deal because the emphasis now shifts towards iterating to say, well, okay, what's wrong with it? Let's go round again. Okay, what's wrong with that? Let's go round again. And gradually converging as we get the solution less and less wrong. Getting it right is a process of iteratively getting it less and less wrong, basically. And I found that this is the most efficient and most effective way of solving customers' problems, of figuring out what they really need. So that's today's little video. Shift your emphasis as a team from delivering lists of features or specs or however you're presented with requirements to solving problems. And don't worry, once you've solved one problem, there'll be another problem right behind it, guaranteed. So you're working through a sequence of problems, organizing as a team around solving that problem and converging on a solution by rapidly delivering iterations, starting with the best guess, but don't spend too long on that guess because there's far more value in the feedback. There's far more value in the feedback than there is in the planning. Okay, that's today's video. I hope you're well. There'll be another video coming soon.